Morning everybody, welcome. Thank you for taking time out of your very busy schedules, I know, to be here with us today. I actually did the presentation on Friday in Bloem, and then they asked me if I was willing to come up to Joburg to do this one today. I'm not going to be doing the one in Centurion or in Durban or Nelspruit, but I think it's different when you get the presentation being done by somebody that knows their product. And it's a bit different when you get somebody that knows all the products and then can do, live comparisons about where, which product fits in. And as you know, as we always advocate for the right tool for the right job, so the right product in the right place. And I'm proud to say that Sig Energy actually does fit, quite a big scope in where you guys are actually all working, whether it be residential or CNI, hybrid, off-grid, all of these kinds of applications. So, yeah, it's an honor for me to do the presentation and then run you guys through it. I've actually got a whiteboard here. I'm going to do some, different comparisons for you guys and just show you a little bit about the differences, about how the various products work. So without further ado, I'm just going to, and what I want this to be interactive. All right, so I'm here. I've got you guys for the next 3 hours. So make the most of it. If you want to know something, stop me, put your hand up. We can, immediately discuss it. And then we can move on, and afterwards we'll also still be, to answer some questions. Jay's going to be here, Eon's here, Jared is here, Kent is here. So everybody that understands the product is here, and then we can maybe, if there's anything that you guys want to know, what kind of solution it fits into. I know that after the Bloem event, a lot of guys literally just jumped on the phone and on sites that they are busy with, quoting the customers and swapped around because they understood the advantages of using a grid-tied with battery versus, a full-on hybrid inverter. All right, so let's get the ball rolling. So Sig Energy is a new product that we partnered with. Jade, like Jade mentioned, it took us quite some time to get to it. So just going to start off with a short video showing you guys, just what they are about and what they are currently doing.
The sun sparks our planet life, lights up human civilization. From far-reaching imagination to everyday enjoyment, we turn light into clean, efficient energy. The dream of chasing the sun inspires and motivates us to innovate further. We embrace every ray of sunshine. Let the exchange between light and electricity never stop. Integrate into every connection, boosting energy to flow more freely. Leading innovation, flexible while efficient, triggers endless potential. Smart control at your fingertips for complete peace of mind. Technology evolves energy. Energy elevates life. Let more imagination become enjoyment. Sig Energy, creating a brighter future. Let the world enjoy green energy.
Okay, all right, so the word Sig Energy comes from a play on, what they're all about, which is safe, intelligent, green, efficient, and new. So although the company is new, 2022 is when the company was founded, a lot of the worry, and especially on our side as well, was, that they're a new company. We went to China to go see the R&D center and the manufacturing facilities and everything, and actually got to meet with the founder. What's nice about them is although they are a new company, as in the company started in 2022, the people and the brains behind the company has been in the solar industry for over 15 years. So Tony Zhu, who's the founder and CEO of Sig Energy, he was the guy and the brains behind it, creating the #1 PV inverter brand in the world and the #1 global shipments for inverters worldwide. He also created the #1 AI computing chip business in China. So he was with Huawei since 1999. We worked at the wireless algorithm back in the telecoms industry. Then in 2010, he took over the PV business. Now, just to give you guys an idea, is the standard for any president in a listed company is a 3-year stint. It's not the CEO, the president that's running it. That's a 3-year stint. So normally what happens is every 3 years, these jobs get replaced by somebody new, somebody fresh thinking. That is how they work about it. He managed to keep that position for 10 years. So just to show you that this is how good he was at what he was doing. So then he went over and ran their AI business from 2020 until 2022. And then in 2022, he decided, look, I'm going to start my own company and build it from the ground up. I can tell you, after personally meeting him and spending a couple of days with him, this is not about money. This is about building the #1 inverter brand in the world from scratch. Because at Huawei, they built it to #1 coming off a big back telecoms business. Huawei was already a big business when they went into the PV space. Now it's about building something from brand new all the way to being #1 in the world. So that is their goal. Their goal is to be the #1 inverter brand in the world within the next 4 years. All right, so the team behind him is 1,500 staff, of which 70% of them sits in R&D. And you can see that their current president's been 15 years with Huawei. The COO, 24 years that he was at Huawei. Their marketing officer was at Huawei for 15 years. Head of integrated R&D, 30 years at Huawei. The head of hardware, 15 years. So he was there when the first inverter was built. And then the head of software is also there since the first inverter was built. Been there for about 10 years. So the entire Huawei family packed up and left with Tony. Yeah, so he decided to go build his own thing and start his dream, and they all left with him. It was not a question of, oh, I'm going to poach you. It was the mutual respect that these people have for this guy. And what I can tell you is, from being in China, everywhere we've been, everybody talks about Tony Zhu. So if I can put it into comparison, for the PV inverter business in China, Tony is like what Steve Jobs is for the computer industry in the US. All right, so money behind them comes from Hill House Capital, Walden International, V-Fund, and then EB, so Eastern Bell Capital. Hill House Capital is the guys that are funding CATL, Longi, Philips, some of the bigger brands out there. They've got $110 billion under investment. And then up to date, Sig Energy has raised only $200 million of capital. And from that, they were able to build a $900 million company valuation. So the company is not small. In 2 years, building a business to almost $1 billion valuation, that takes a lot of time and effort and a lot of skills. So in Shanghai, they've got 2 buildings. The one is their R&D center and their headquarters, which is a 10,000 square meter building in Shanghai. And then they've got a 20,000 square meter manufacturing facility at another site in Shanghai. And as you can see, there's PV on the roof on both of these, and both of these actually run off the actual product. The actual production line runs from the inverters. So the headquarters is in a business park where they've got Sig Energy deployed across the business park, and they've got them outside for EV charging, all of that. It's all set out outside of the building. All right, so here's another short video. So if some of you guys saw the back end of that video, they showed that there's a burn-in test. This means that every single inverter that comes here has spent 2 weeks inside the most extreme conditions before it gets shipped. So it's not a sample that gets picked, 1 out of every 100 inverters that gets tested. Every single inverter goes into a room running at 45 degrees Celsius, running the inverters at peak load, pushing them for 2 weeks. Then they go out, they go into minus 25 degrees freezer rooms, working inside there. Then they go out into a room where they hit them with lightning. So there's a lightning, I mean, there's a video that's on our group that you guys can see, that where they actually do a physical lightning test on them to make sure that these inverters are robust and made for the global markets. All right, so one of the biggest things and why Sig Energy came about is, the slide says, to remove industry pain points with an innovative solution that's simpler, safer and smarter. So the Sig Store is the product that is currently available. Next year we will have Sig Stack available. So Sig Store won a Red Dot Design Award, for the way that it looks, but we all know it's not about how it looks, it's about how it works. So the system consists of a full 5-in-1 solution. Now, this is the first part where you need to get your head wrapped around the design. So when we say the word PV inverter, it's actually grid tie. That's what a PV inverter is. When we say PCS, it's power conversion system, so it's an inverter that does from battery conversion over to AC power. So what they've done is they've literally combined, so a good option of PCS is, 8S, PCS inverters, that's just basically a battery inverter. What happens here is they've combined PV inverter for maximum efficiency with a PCS for maximum efficiency, and then put the battery pack down at the bottom with an integrated EMS that is fully functioning as a world-class EMS. So no external EMS is needed, and then obviously you can stack in a DC EV charger that has got way more flexibility than what AC EV chargers has. All right, so if you look at the design up here, you'll see that your inverter always goes at the top. Then your second stack will be a DC EV module if you want to add a DC EV charger. And then you can stack up to 6 batteries. Up to 6 if you don't use the DC module. If you use the DC EV charger, only 5 batteries. So the limitation is 6 DC stacks with the AC converter at the top. The inverters are 300 by 260 by 700 wide. That doesn't matter if it's a 6 kilowatt single phase, 8 kilowatt single phase, 10 kilowatt single phase, 12 kilowatt single phase, or 5, 10, 15, or 25, or 30 kilowatt 3-phase inverter. They will always be that size. That's it. So all the inverters are the same physical size, which means that if you've got a site where you maybe need 20 kilowatt single phase, you can use an 8 kilowatt single phase inverter and a 12 kilowatt single phase inverter. Put them next to each other. It won't look funny with small and big. They look uniform, and you will have 20 kilowatts worth of AC power. So you can mix and match on single phase any different sizes together, and on 3-phase also any different size. So you can do a 25 and a 5, and that'll give you 30. You do not have to have the same inverters when you run them in parallel. Okay. Then on your batteries, currently available 5 and 8 kilowatt hour. We only stock the 8 kilowatt hour, and then 10 kilowatt hour will be available in January. So the batteries will also only be 270 by 260 by 700. Doesn't matter if it's a 5 or 8 or 10, they will always be the same size. So again, with the batteries, same story. You can mix and match 5s and 8s and 10s together. You can also mix and match 1-year-old batteries with 10-year-old batteries. They do not affect each other. There's no cask effect. There's no watering down, the newer battery gets pulled down by the older battery. Because the way that the architecture works, each single module and each inverter runs on its own. So it's like different devices, and all of them work under their own conditions. So if you add a new battery, in 5 years from now, that battery's warranty will start at that date automatically. And that battery, even though it's got way less cycles than the previous one, the system will automatically use whichever battery it needs to use to make sure that you get the most energy out of the system. All right, and then your DC EV chargers are 12 and 25 kilowatt hours, or 25 kilowatts. All right, so the idea is we want to do a simple, fast installation. So all of these units come with a quick connector, which means drop and go. Put it down and it's connected. So it saves 70% of your time from not having to wire up all of them. Then it does a fast commissioning. It takes roughly about 5 minutes to do a full site commissioning. It's one-click diagnosis, which means that once you have built the site and you scan the barcode and you want to start commissioning, it will do a diagnosis first and it will say to you, stop, that inverter, that MPPT, you've got the positive and the negative on the DC string the wrong way around. Hang on, inverter 2 on your 3-phase system, you've got a phase rotation error, fix it first. So it'll point out exactly where the fault is before you can commission. So it literally does a scan and sees where the mistakes are, and then those mistakes gets reported and it tells you exactly which ones to fix. The other thing is the stackable solution makes it a 2-person job on any site. So no heavy lifting equipment, no forklifts, no pallet jacks, no nothing needed. It's just a 2-person job on every single site. Doesn't matter if you are building a 6 kilowatt home installation or if you are building a 300 kilowatt big hybrid commercial site, you will only need 2 people to do that entire job. Look, 2 people is going to take a lot of time for the panels on the roof, but for the AC side, you do not need to have a forklift, a truck, anything like that. You can just stack it with 2 people. All right. So the batteries themselves is been designed to use 280 amp hour cells. Now, as the industry is progressing, the 280 amp hour cells are now coming 315 and 320 amp hour cells actually give you much longer cycle life because the technology is so much more advanced. It's the cells that gets used inside EVs. So on the 5 kilowatt hour battery, you will have 6 cells inside the battery. On the 8 kilowatt hour, you will have 9 cells inside the battery, and on your 10 kilowatt hour, it will also be 9 cells, but it will be the 315 amp hour cells that's going to go inside there. So your battery as a unit has a static voltage of 32.85 volts, which is safe for human touch. So the idea was to not have it at high voltage out the box, so that if somebody for some reason has a way of getting a way to get a spanner or something in between the 2 connections, the flash or close, there's no flash because there's no high voltage for the jump, so that it's a safe voltage before the battery gets started up. And this also because you're using 280 amp hour cells and now 320s. Now you will see that CATL and these guys are already developing 400 amp hour cells. Those 400 amp hour cells will be the physical same size, weight and dimension of these, which means that that is the logical next step of what size your battery is going to be, because it will always only be 9 cells. That's how the architecture works. All right, so inside your battery, you've got a 5-layer protection. So the first thing is you've got 7 active sensors inside the battery that detects cell temperatures and temperature variations, so that it can give early warnings if some cell is potentially having a thermal runaway event. Then in between each cell, you've got aerogel. That aerogel stops the heat from one cell to transfer to the next one. So if you've got one cell running hotter than the other, there will be no temperature transfer from the one to the other one. Then on the side of each battery, there's a decompression valve. That decompression valve will open in case there's any pressure buildup inside the battery itself. So it'll open up and it will release the pressure on the inside. Then also around the outsides of the casing and the bottom at the top, they've got a temperature resistance insulation pad. This is what enables the battery to work from minus 25 degrees Celsius all the way up to 60 degrees Celsius ambient temperatures. So those insulation pads stop the heat from the outside or the cold from the outside coming in. And then as a last defense system, if something were to happen and all of these others have failed and not get there, each one of these have got a fire extinguisher built inside that has got a aerosol gas release inside there. So if you take container builds, we use the same kinds of aerosol gases inside the containers. So what happens if there's a fire, the aerosol gas gets dispersed, it kills the fire, and then the gas stays inside the container for roughly about 20 to 30 minutes, before it like dissipates, but 20 to 30 minutes is long enough so that there's no reignition that can happen. Because one thing about lithium is, you can hit it with a fire extinguisher, wait like 5 minutes, and boom, it starts flaming up again. So this gas makes sure that there's no reignition. Inside this unit, when that gas goes off, the valve stays closed, and that gas remains inside that battery for up to 6 hours. So it's just to make sure that there is no reignition so that you can remove it and get it away. All right, then on the system side, there is also 5-layer protection, which is PV disconnect protection. It does have it built in, okay? It's got arc fault protection built in. It's got DC ground fault protection built in to make sure that if there's any leakages to earth, that it's there. It's got a DC bus protection on the battery side, so to make sure that there's no overcurrents and over voltages flowing in. So, and then it's got grid fault protection built in. So if there's any grid failures or anything like that, that it islands off. So it's got an isolator and a fuse on the inside. It's got an isolator and a fuse in here, and it does have earth leakage protection in there. So no need for anything because it's all built in to the system. Now, what the nice thing is about the way that they connect their batteries is that the battery connection is a parallel connection. So if you stack 6 batteries, all 6 of those batteries are running in parallel with each other, which means that you do not have a series connection, so you do not have the full battery draining into the empty battery. What also makes this nice is that today you can install cell vendor A, so let's call it CATL, is the brand of cells that's the best in the world at the moment. So you've got an 8 kilowatt hour battery. Then you've got a 5 kilowatt hour battery. Now in 5 years from now, maybe BYD comes out with a better, higher energy density battery that is much better than what the current CATL units are. They can swap out to a different cell vendor and still add that battery with the other batteries because they are all running separately. So each one of these batteries has got a battery optimizer in them. So what it does is it takes the 32.85 volts, boosts it all the way up to 600 for the inverter to accept. So when you have a battery that's dead over here, those two can still keep your system running. So anytime you lose a battery on the system, it stays on. It just red lights that battery, sends you a notification, tells you that that battery needs to be replaced. The system does not go off. It does not die. If you've got 10 inverters or 5 inverters running in parallel through the gateway, you can literally switch all 4 of the inverters, the system will still stay on. It does not fall over because there's no parallel comms that it will have a parallel failure event. It stays on. The only thing is your limit then becomes less. But what will happen is automatically, if you have one inverter that fails, it will just take from the other inverter, and if that's not enough, it'll take from grid or generator or whichever source you wanted to do. So it's if you're ever in Cape Town, you can actually see it there because I let people just switch off the inverters like they want to, and the power just doesn't go off. It just never dies. So with others, you have the problem, if you add an empty battery to a full stack, you've got the cask effect or you've got errors. That's the two things that you have. Here you do not have that problem. You can literally go and replace a battery that's full on a stack that's halfway charged. Just put it down, connect it, screw the screws in, pack your shit up and leave. You do not have to commission it. You do not have to program it. Once you remove the old battery or you add the new battery, so let's say you've got a customer that's got a 6 kilowatt inverter with an 8 kilowatt battery. All you have to do is you come to your gateway, you switch off the inverter. So when the inverter has been switched off, this will get power down. You switch off the DC side, press the button, it's dead. Power stays on because it's gone back to grid now. Take off these covers, 3 screws here, 3 screws here. Take off the inverter. As you take the inverter off, you put the next battery down, put the inverter on top, 3 screws, switch on, leave. That's it. You do not do anything else. It'll automatically pick up that a battery has been added. It'll increase your capacity from 8 kilowatt hours to 16 kilowatt hours, and it'll continue working. The new battery will automatically register the warranty, and it will show you that this battery warranty started on this day and this one started at this day. And this is the expiry date. All right, then the DC EV charger is V2X ready, which means vehicle to grid or vehicle to home. So in Australia, they're allowing it. At the moment, it's only the Nissan Leaf that allows bidirectional charging, but I believe that some of the other manufacturers are getting on board with it. What actually happens is you can either use the battery inside your vehicle and send it to the grid to export during peak times, or once your battery in your house is flat, just pull out of the car. As long as the car's plugged in, you can use the car's battery to power your home. Gerry actually just bought an EV, and we've got a nice big 80 kilowatt DC charger at the office. So it takes about 20 minutes to charge his car from empty to full. So now he's on the call with BMW because he wants vehicle to home enabled, because he wants to install a Sig Energy. So all he does, he comes to work, plugs in his car, charges it full, goes home tonight, plugs in his car, and then drains the battery. I think the one thing that sets them apart is this. So this is actually where all the magic happens. Now, I know a lot of people are saying, oh, you don't need a gateway and everything's built in. It's not the same. It's not, you cannot build a gateway into an inverter. What the gateway actually does is it allows you the connection of multiple inverters without having to parallel them, so that you can literally have redundancy on the system, which means that if we have 5 stacks and we have failure on one, we do not have a total system shutdown. If we have to do maintenance on one, so we've got 2 inverters running in parallel, want to do maintenance on one, switch it off, do the maintenance, switch it back on, the system stays online. The gateway makes sure that the system stays online the whole time. So inside the gateway, you've got your connections for the inverters, you've got your 2 contactors, and you've got your grid and your smart port at the top. Then inside that little piece there is a PLC. So that PLC is actually the thing that enables them to achieve 0 millisecond changeover. I was a skeptic about this. I was a skeptic for a very long time. I got on a plane and I flew to China and I wanted to see how it gets done. Now, there's portions of it that they're patented secrets, and then there's a portion that we could share with all of you guys. But just in very easy explanation, what they do is they pulse the grid voltage and grid frequency amplitude 32,000 times per second. with the PLC. So if you have a grid failure, normally what it looks like is, so you've got 0 volts here, you've got 230 volts there. This is how your grid looks, and then you've got the failure, it does that. But if you extrapolate this into 32,000 measurements per second, you actually end up with something that looks like this. That's actually what it looks like. So what they do is they detect this happening, stabilize the voltage and the frequency on the output side, and just let the grid go. So there's no grid inverter switch that happens. It's literally, I am running, I am taking the loads, we're powering the system, we've got the grid here as backup, we're going to use the grid whenever we need it. Hang on, there's something wrong with the grid, let it go, just continue by yourself. So that's basically what this system does, is it detects the grid voltage and frequency amplitude, and as it sees it happening, it just lets it go. In their factory, they run the production line on this system. There's a breaker on the mains that they've connected a motorized unit to with a button as a demo or test. So you've got two ways you can see 0 milliseconds changeover. You can look at the scope, or you can just look at the factory floor that is busy running, and then press the button and switch the grid on and off and also watch the factory continue to operate. So you know what a production line does with even 20 milliseconds. VSDs do not like any interruptions. There's a lot of things that do not have it. With 0 milliseconds, it's as good as true online UPS, which means you can run data centers and medical equipment on it as well. All right, then they've got an AC EV charger, which is just an additional product to this site. If you do not want to use a DC one, you can use an AC EV charger. The other thing is you can also use the inverter just as a grid-tied inverter. So you've got three options. You've got the inverter as a grid-tied, or you can do grid-tied with maximum self-consumption, so you add batteries to it. So no gateway, which means that during the day, solar will be pushed into the network. At night time, it will also charge the battery. At night time, it will discharge the batteries into the network. So countries that have a stable grid, this works great. So PV with battery. So it's just maximizing so it's taking your curve like this and extending it over a longer period in the day. Then if you want backup, you add a gateway. The gateways come in 60 kilowatt on the three-phase, in the single phase it's in the 12 kilowatt and a 25 kilowatt or 30 kilowatt. On three-phase it's going to be a 60 kilowatt, 120 kilowatt, 180 kilowatt, 300, 600, and 1.2 megawatts. So those are the sizes that's available. Currently we are feeling very safe with doing 1.2 megawatts, 0 millisecond changeover on Sig Energy. Once the Sig and Stack releases, we'll be able to go up to 10 megawatts. So that's just going to be a bigger inverter with bigger battery topology. Now, I want to just give you guys a bit of an idea on how the different technologies work. So I'm going to just take a standard, whatever brand inverter you've got here. Okay, so that'll be your standard inverter setup right now that everybody has. So what would you say is the PV voltage generally? Roughly about 500, eh? Okay, and the battery voltage? Okay, so these are DC, eh? And then the grid is 230 AC. And here we've got 230 AC. Okay. So, if I want to use the PV generated tonight, we have to store it in a battery. So what are we doing? We're taking 500 volts DC, pushing it through a hybrid inverter, converting AC DC, down to 52 volts DC. How much losses do you think is actually happening inside there? Then we take 52 volts DC, we convert it back to AC, step it up to 230 volts, and then use it. So if we were to say we are sending the 1,000 watts through here, down there, back up there, through here, how much do you think is actually coming out here from the 1,000 watts that was actually hitting your panels? About 860 watts. So yes, I mean, we've got so much sun in South Africa, who gives about that? Nobody cares. But you should actually care. Because the majority of the systems that we see, people are undersizing the PV. Because space constraint or budget constraint. So, I mean, we've got a lot of people that are saying, no, my batteries are drifting. But the batteries actually never get to 100% and actually start balancing because of not enough PV. Now, not enough PV, if you are losing 140 watts in the cycle, if you had enough, or you actually do have enough PV, you just have too many losses. That happens through the system. So here we have 110 millimeter water pipe feeding water to the system. If this is, so in essence, 60 amps. Here we've got an 8 kilowatt inverter. That means that we've got 32 amps is our limiting factor, which means we are basically putting in a 50 millimeter pipe with a reducer up into the 100 mil, which means that there's no ways you're going to get the delivery from that water out this side if we're reducing the pipe size. Okay. So your limiting factor here is 8 kilowatts. The problem is your limiting factor is 8 kilowatts. Doesn't matter whether it's coming from PV, from battery, from grid, or whichever way. That's it. So what you're basically doing is you're going, let's have a 50 millimeter pipe there and another 50 millimeter pipe there, and we join them all together, but we put a tap on. So we have got a source, a source, a source, and we're reducing it to only one way of getting it out. So even if this pipe was like 200 mils, and this was like a 300 mil pipe, putting that tap with that reducer in, that's the only flow that you're going to get out of it. And that is the total limiting factor. So if the load is 4 kilowatts here, that can only deliver 4 kilowatts to the battery. If the load is 8 here, you are not charging batteries. There's no ways it's happening. So on a grid-tied system, what does it look like? So you've got grid, and you've got load, and you have one straight 110 mil pipe. That's your limiting factor. Because where does your grid tie inverter come in? Comes in here. Okay. So what happens now? What is the amount, if we've got a 50 mil pipe here, what is the amount of water delivery we can get on the other side? 160. Because we've got 110 from the grid and we've got another 50 coming in from the inverter side. Which means that your limit is actually, yeah, you can draw more than what is available from grid during sunlight hours. So the only thing that Sig Energy does is it basically puts a gateway in there. That's why that gateway's got a 100 amp breaker in it. So you can supply from the grid as well as from here. But here's the other magic. What looks like here is there is your battery and there is your PV, and they are on the same DC bus. So now we have voltages. Let's go back to the orange one. 600 volts here. DC. Is that bad? Okay. Let's do black. We've got 600 volts DC over here. We've got 600 volts DC over here. We've got 220 AC over here. When we are charging the batteries, it's DC-DC. There's no conversion to AC. It's at the same voltage. There's no voltage step up or step down. When you are supplying AC, you've got 600 down to 220, not 50 up to 220, which means that your losses are way less. So your 1,000 watts of PV getting generated, that comes out here, is that, even if it has gone through the battery. The amount of efficiency gains that you're getting from having a DC coupled system. Now, I'm not just talking about Sig Energy, because if you take any other brand that has got a high voltage DC bus, it basically looks exactly the same. It's just there that it differs. So you've got grid, you've got load, your inverter, and then you've got PV and battery over here. But your PV and your battery is on the same DC bus, so you've got single conversion. The only difference here is this is again your tap that limits it, where here you do not have a tap that's limiting it. If you've got a 6 kilowatt inverter here, and you have got an 80 amp connection over there, you can draw 100 amps when the grid is available. Again, understand that that is a 110 mil pipe, that's a 50 mil pipe. If we shut off that 110, we've got the limited flow of the 50. That is why the smart port is inside the gateway, so that you can connect your heavy loads to the smart port or a generator, and you can then say, if the grid fails, start the generator just to handle peaks, or just put my peak loads on the smart port. When the grid fails, just drop them out and don't use them. The other benefit that you have is a 6 kilowatt inverter can take 12 kilowatts worth of PV, which means you can send 6 to the battery and 6 to the loads. Here you've got an 8 kilowatt full limitation. So even if you've got 10 kilowatts worth of PV here, 8 is the limit. And if you are sending 8 to the battery, 0 for load. As soon as you start taking on load, you lessen on the battery. Here, battery takes what it needs, loads takes what it needs. Because you are on the same DC bus. Then your app, Myen app, available for iOS, macOS, Android, and Windows. There's 2 versions of the app. Although you download one, the login determines what functionality is available. So commissioning can only be done by an installer that has been trained and uploaded their DOL documents. Then you get access, then you can do commissioning. Once you've commissioned and you've set up the system, it'll ask you for the owner's information. You input the owner's information with his email address, then it sends him the login details, and when they log in, their app has got different functionalities available. They've got nice functionality like, oh, let's change the light from green to blue. They've got, I can input my electricity tariffs, or I want to have 60 or 70 or 50% battery backup. Those are the functions that's available for him to change. Or I want to be in self-consumption mode, or I want to be in Sigen AI mode, or I want to be fully feed into grid. That is what they can choose. They cannot set grid code settings. They cannot set anything else. And you cannot set the charge current for the batteries. Nobody can. Only Sig Energy can. So the AI decides how hard I should charge the battery. The AI decides which battery in the entire stack I'm going to be using next. So it looks at cycles and then sees inverter stack number 5, battery number 4, that's where I want the power. So if you look at it on a big system like we have in Cape Town, we've set the lights to show you the depth of discharge, and so when it's blue it's discharging, when it's green it's charging. So if you look at it, you'll see that now that inverter is blue, now this one's blue. Now 3 of them are blue, now they're all green. So then the AI decides which battery we're going to be using to make sure you've got equal drain over all the batteries. So if in 5 years you add another battery, it'll most probably use that battery more and save the others to make sure that you've got an equivalent life cycle over your entire system. It also does, if you've got AI enabled, so I want to export my battery at 6 o'clock in the morning when there's peak times and we export to the business next door. At night time, so I dump my battery 6 to 8 at night. Then I go onto grid power. Then at 10 o'clock I start charging the battery because the rates are low. It does not charge the battery full in 1 hour. It determines I'm going to need this battery 6 o'clock tomorrow night. So I have from 10 o'clock until 12 and then until 6, so I've got another 8 hours to charge it. So I'm going to fill this battery over the next 8 hours. I'm going to charge it at 20 kilowatts. And it just does that. Each inverter has got a Wi-Fi module built inside to the inverter. So each device has got Wi-Fi built in. They also have Ethernet FE ports in and out, so you daisy chain straight Ethernet. And then they've got a communication module that takes a SIM card, and it's got an international SIM card in it. It's got reception in major metros, but if you're out in, there's nowheres, just pull it out and they slap in an MTN or Vodacom SIM card in there, and it's got connected. So it's got a 3-level, internet failure failover. AI-empowered self-evolving system. So what's nice about this, it's not just about peak and off-peak charge and discharge. It actually learns. So it learns, if you start the AI assistant, it'll learn that, every day, roughly at about 6 o'clock, there's large power draw. Every morning at 4 o'clock, there's large power draw. So it starts learning and then it makes predictions. And then make sure that the batteries are charged to also based on what the tariffs are at those certain stages. And then it also has the ESP app plugged into the system so that when we are currently using our batteries for arbitrage, so we are going, buying at low rates, selling at high rates, buying at low rates, selling at high rates, and all of a sudden Eskom says, stage 4 now, power is going to be off in 2 hours. The system will see, I'm going to be off in 2 hours. The current load is 20 kilowatts. Based on what I've learned over the next few days, within the next 2 hours, the load is going to peak up to 30 kilowatts. So I'm going to need at least 60 to 70 kilowatt hours inside the batteries to cover that. So we need to charge the batteries now over the next 2 hours at this rate to get it there so that when load shedding comes, we can switch over. It's got an algorithm that gives you advanced warning for potential safety risks. So, you've got these peaks where you are using a lot of power. Now, when you're using, there's cells that might have a drift or something, it picks it up, it automatically pre-warns. Your warranty, the app will let you know as the installer that there's a battery that has abnormal cells, it needs replacement. Can you replace it? Pick up a battery from Harold's, or we'll send one to the customer or send it to you. You go out and you replace it and then you leave. So it does pre-warning and all of the warranties gets done via the app. Also, there's no repairs. Everything is replacement. So if you have a warranty, it's literally they're aiming 48 hours. If you're a service partner, you're registered as a service partner, you've got a warranty claim on a battery site, they will actually pay you $150 to go and replace that battery. If you cannot attend to a battery replacement that you have been logged, what will happen is they will contact the next nearest service partner to go and do that. So you must understand the system is for installers. It's designed for installers, but it's also to have the end user up and running. So if they cannot get that end user up and running because Zon is too busy on a roof to go and do a battery replacement, they're going to ask Tinus to go and do it. And you have to be fine with that. So you will be the first call to do it, but if you are not able to do it, the next guy will be asked to do it. Okay, and then obviously it's got the AI assisted customer service with ChatGPT built in. So literally all of it is that like to not read the manual, just ask AI, it will read the manual for you. Quick wrap up. It's a 5-in-1 system, 0 millisecond changeover, bidirectional EV charger, 5-layer battery protection, built-in AI, and using 280 amp hour long cycle life battery cells with a 15-minute stackable installation and 5 minutes fast commissioning. And that's the truth. So the AC, so on our building in Cape Town, 250 kilowatt, 500 kilowatt hours. The roof team with 400 kilowatt PV, the roof team was busy for 2 weeks. The AC side, 9 o'clock they started, 2 o'clock they were done. So packing, stacking, wiring, everything, building the entire system. That's how quickly they built a 250, 500. And it was their first one. I can promise you their next ones will be quicker. All right. It's also great for commercial. So instead of having these big inverters with big batteries that you have to crane around, you literally just stack and stack and stack and continue, and you parallel and expand the system where you want. All right, so the whole idea is boosting the ROI. So 20% CapEx saving, 85% operational expenses saving because of AI. That just saves you so much on the O&M. And then 5% higher yields because we can actually over panel and we can use the battery in specific times through the AI assistant. Okay, their roadmap, like I said, currently A1012s, 30 kilowatt inverters available, CNI gateways are available. The 100 kilowatt PV inverter, we've actually got a demo unit here somewhere, and then the Sig stack, which is going to be the bigger batteries. That's going to be up to 110 kilowatt inverter with 225 kilowatt hour worth of batteries on the stack. So Sig Store has EMS built inside. It's IP66 rated, so you can put it anywhere outside. I think this is actually something I should touch on. So if we have installation, let's take this building for argument's sake. So actually a nice installation that we've got here. So you've got your PV on the roof. Okay. So then we've got our inverters inside the building, and we have our loads and our grid input, and we've got our DC cable running there. Where do you think the most losses happen? Here, on the 4-core 70mm cable, or on the 6mm DC cable coming from the roof? That's where the most losses happen. So now you've got one big inverter, central location. You've got this big roof. So the panels on that side, DC cables are way longer than the ones that's right up here. So you're having losses from the panels on the other side, have to maybe upsize the cable, increase the BOS cost, all of that. With Sigenergy, what you can do is your gateway goes here, loads and grid and generator, and then what you do is you stick one stack of Sig Energy batteries and inverter here, stick another one here, stick another one here, stick another one here, another one here, and you have your DC cables going in there, and here you have your AC running into that gateway. And that's an AC cable which has a lot less losses than what the DC cable does. Also runs a lot cooler, doesn't run as hot. So at the end of the day, You can decentralize the system. Take this building. We could stick Sig Stores around the outside and just feed all the AC cables to the inside. You've got a building that's 5 stories high, PV on the roof. Stick the inverters under the PV modules. Short DC runs. Bring all the AC cables down in the services shaft. In the basement where your connection normally is, put your gateway, come in with your AC cables all into your gateway. So your gateway is a fully AC connected system.